तो अब से तुम कंडक्ट करवाओगे क्या? You will be conducting sessions? Conducting in the sense presenting. Like you have to inform the consultants now that they have their classes. No, yes, as to that. Just because Anjana ma'am turned out to be positive. Okay, but who will be doing that now? Because there are some classes of Seema ma'am and all. So you have to inform them. They will make some arrangements. And Sir will be doing class 2. Yeah, I'm just telling कि तुम देख लेना किसी को बोलना है तो हुआ क्योंकि नहीं तो क्लासेस नहीं बंद हो जाएगा ना because हम लोगों को बोलने से we will be doing the practical classes but we can't take the lecture classes but in the morning I have to take the lecture class. Yeah, I took the lecture class no in the morning. Ganesh sir and after that I took the lecture class. It was the continuation of this. Yeah, actually I told ma'am if I am doing the practical, there is no issue. There is no use of it, na? Just starting the practical and laboratory techniques before telling the actual briefing and all. If I have to take the lecture class, then make it a continuation, the lecture, and followed by the laboratory techniques to demonstrate it. Let's see. They're joining, na? There is Jasmita's class also today, 1:45. लोग अनम्यूट कर सकते हो 3:40 से स्टार्ट कर रहे हैं मूवी दिख रही है क्या मूवी दिख रही है क्या ओह सॉरी हाँ मेरा वीडियो भी आ रहा है माय वीडियो आल्सो ओके यू डोंट वांट द वीडियो क्या वीडियो ऑन करने को ओके हम बोलो चैट में कुछ आया था ये लोग नाम लिख रहे हैं स्टार्ट कर दूँ क्या? कितना है? 100 देखो 215 में से आगे 20 लोग आए। लेक्चर also 37. But everyone are giving attendance now and they are leaving. Means how can they give attendance? This time it is not needed. As I said, morning session we will take it out. Yeah. Morning session, how many people joined? I didn't check. Answer. So where is that attendance sheet? This is attendance sheet. Morning we took in some other sheet. For practical, they are taking it in this sheet. This nobody is attending. For these many they were attendance, but people left in the field. Oh, it started from 2 today also. What was the practical class then? That time case study was there regarding that morning class related case study. Okay, who took the class? Ganesh sir. Okay. Oh, so at 2 they all joined and then they left in between. Now the second session. And I get closing. अच्छा कितना करूँगी ये एक और फोटो नहीं अलग है हाँ है फोटो अलग आएगी अलग आएंगे ठीक है आपका स्टार्ट हो गया नहीं अभी तक तो स्टार्ट नहीं किया अभी कर दूँ अलग कर दो ना फिर हाँ 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 मैं करते स्टार्ट कर देते हैं और कितना है हेलो am I audible am I audible
You're audible. You can hear you're audible. I can hear you.
Okay. So I will start from the morning session. It's just a continuation of the morning session where I stopped till the cytochemistry, the MPO, the Sudan black and the pass. So I move forward to the advanced laboratory techniques. Mostly it is an overview type of class. The first technique is flow cytometry and immunophenotyping. Second is karyotyping. And the third is next generation sequencing. So all the blasts, though they are different looking morphologically, but sometimes they mimic. But how will you say that confidently this is myeloid blast or this is B lymphoid blast or this is T lymphoid blast? There must be something that will discriminate them at the molecular level almost. So there are some CD markers associated with them. Fewer lineage specific markers and fewer associated markers. What are the lineage specific markers? Just think of your name. It's like the proper name and there is a surname. Those lineage specific markers are like the surnames that say, okay, this cell belong to this lineage, like the Sharma lineage or Mishra lineage or something. And all other markers are like the associated marker, that is your name. So in the myeloid, the lineage specific markers is MPO. In any cell, if you get MPO positivity by cytochemistry or by flow cytometry, this is a myeloid. But there are some associated markers also, like CD117, CD13, CD33, CD14, CD64, CD41 and CD235A. If you can't remember them all, and you shouldn't also, so you just remember that in myeloid blast there should be MPO positivity, and also they can be positive for CD117, CD13, 33. What is the need of this 117, 13 and 33? Because I told you that M0 blasts are the most immature blast, so they can be MPO negative. But by what we can identify them? By the other associated markers. And few monocytic myeloid blasts like M4 or M5, they can be MPO negative also. So then CD14, CD64 will help us because these two, with CD14 and CD64 are myeloid markers. So, and the B lymphoid markers, the lineage markers is mostly CD19. If a cell is CD19 positive, then we can say this is a B lymphoid cell, like B blast or B lymphocyte. The other associated markers are CD10, CD22, CD79A. In the presence of CD19, we can say it's a B blast, but if CD19 is negative or CD19 are expressed in few cells, so they, but CD10 or CD22 or CD22, CD79A are present, we can again say it is a B blast. What is the CD? What is the full form of CD? Do you know it? Anyone? Adarsh? Hello? Who else are there? Huh? Yeah, Avinav? Avinav?
Yes, ma'am.
Yeah, what is the full form of CD?
Clusters of differentiation.
Yeah, this is a cluster differentiation marker. This is present on the cell surface. So if it's type of an antigen, and if we give an antibody binding to against them, and also a fluorochrome with attached with them, so we can check that if it is CD19 is present or not. Okay, so this is cluster differentiation. And T lymphoid marker is mostly CD3. All other associated markers are CD4, CD5, CD7, CD8, etc. Just for remembering, I want to say T comes after B, but the markers associated with T are less numbers, like 1A, 2, 3, 4, 5, 7, etc. are T lymphoid markers. But the larger values like 19, 10, 22 are B markers. You can remember it by that. So now you know that what are the lineage markers and what are the associated markers. But how will you differentiate it? How will you get use it? So this is a flow cytometer. Here what we do, like this purple thing, just assume it like these are attached to the cell surface. These are the CD markers. Now we are giving them the antibody against it. Like if it's a CD8, we are giving CD8 antibody along with a color like a fluorochrome. If they get attached to it, we will get a signal in the laser. If it doesn't get attached, then we won't get. So we can see here they have used CD45 and CD34. So this cell is have attached with both CD34 and CD45. So this is CD34 and 45 both positive. This is mostly blast because 34 is a stem cell marker, CD34 and TDT. It's the immaturity marker for all cell lines. These cells have attached CD45 only, but negative for CD34. So mostly they are hematological cells, but not immature cells. Okay, by it we can differentiate it. So here we have used CD45, CD34, but now we can use CD3 and CD19. If it's come positive for CD19, it will be B blast. If it comes positive for CD3, it will be T blast. Also, we can use the 13, 33, 117. So if it is positive for MPO, CD13, etc., so it is probably a myeloid blast, and if it's not, it is not a myeloid blast. So next we can go with the karyotype. But what is the use of this karyotype? Why will you do it? In the morning I told that there is WHO classification. What was the first classification criteria? It was the AML with recurrent cytogenetic abnormalities. All the malignancies in hematological malignancies or all other soft tissue malignancies or solid malignancies. What is the key point? A mutational event.
It can be a driver mutation, it can be a secondary mutation, etc. So obviously in the genetic level, there are some alterations. And according to that, we have subdivided the AML and also the BLL. So we need to do a chromosomal karyotype. In the chromosomal karyotyping, you get somatic chromosomes from 1 to 22, 1 to 44, the pairs, and again X and Y. So if you see this karyotype, what is the diagnosis? Sorry, what will be your diagnosis? Oh my God. Anybody? All the somatic chromosomes are present along with X and Y. So it's a normal male karyotyping where there is no abnormality. All are normal, but if there is no Y and double X, then it will be a normal female karyotype. So in BLL also, we have subdivided it according to the recurrent genetic abnormalities like translocation 922, translocation 1221, and hyperdiploidy, translocation 514, etc. So what will happen in translocation 922? A part of 9 will go to 22 and join with that. In 1221, again a part of 12 will be added to 21. And by seeing those abnormality, we can say, okay, this is a BLL with 922 chromosomal abnormality or BLL with 1221 chromosomal abnormality. In case of AML also, it is very important because in the morning I told you that in few cases of AML, it's not needed to be not needed to be present 20% blast. So what are those? Can anybody say? What are the chromosomal abnormalities where presence of 20% blast is not needed? Anybody? Shubham? Hardik? Harsh? Anyone present? What are the abnormalities where presence of 20% blast is not needed? Hardik? Dhananjay? Nisha? Nisha is there? अरे कोई भी बता दो. In the morning you gave that answer na, that AML with 821 or inversion 16 or APML 1517, it's not needed 20% blast. उसके अलावा सभी AML में 20% blast होना जरूरी है. So AML with recurrent genetic abnormalities, we can divide it into translocation 821, inversion 16, translocation 1517, translocation 911 and 69. There are many more, but those are important. So now almost and in next generation sequencing, you do the whole genome sequencing for the important mutational point to where the genetic alteration is getting done. So you can have NPM1, SEPA, IDH, etc. by that next generation sequencing. But we don't do it always. We can go with flow morphology followed by cytochemistry and then the flow cytometry. And if we are suspicious, we can do the karyotyping for the recurrent genetic abnormalities. So just tell me, what is this cell? Which of the cells shows a bilobe nuclei, which is like apple core like of type of nucleus? One. Shubhashini, Dr. Shubhashini. Okay. Gagan. Gagan? Aryan? Shibhashini, you say. You say. What is this type of nucleus? Where it is seen? This bilobe type of nucleus, this apple core type of nucleus. Where do you see it?
Rome myelocell.
So what will be your diagnosis if you get this type of cells?
Respect to traumatic APML.
Okay. Okay, good. So this is a case of APML where you get this type of bilobe nucleus. And what is this structure? This thin structure, and what is this stain which is giving the brown color?
Or road and Houston.
Yeah, this is or rod, this is ampiostain. And if you get it all together, then what will be your diagnosis?
AML
Yeah. And in a nutshell,
means
what I told, what is or
mileage.
rod? What is the or rod?
Ma'am, lysosomes get condensed together.
Yeah, this is a
So
lysosomal aggregate, crystalline lysosomal aggregate. Okay, and this is ampiostaining, giving a brown stain. Good. What is your name?
Abhinav Agarwal.
I think only Abhinav is differentiating. So what is this cell? Having multiple or rods in a crisscross-like fashion. The typical name of a,
Faggot cell.
yeah, this is a faggot cell. And where it is seen? If you get this type of cell and a very strong impure positivity, then what will be your diagnosis? What do you see faggot cell and strong impure positivity? Almost 100%.
APML.
Yeah. In APML, you get 100% positivity for impure almost, and there you will see this type of bilobe cells and also characteristic faggot cell. Now say me, which is abnormal? This cell or this cell? And why? Which one is abnormal and why it is abnormal? Ishan?
Yes, ma'am.
Yeah, which one is abnormal, the left one or the right one? This one or that one?
Ma'am, you changed your slide.
No.
Yeah, now it is.
Yeah, yeah. Which
So,
one is abnormal?
like on the right side, there are more blastic blast cells, whereas on the left side, you see a neutrophil and more mature cells. So that is normal.
Yeah,
Relatively.
this cell
This,
is a normal lymphocyte and this is a normal neutrophil. But this cell is a blast because you can see there is high nucleocytoplasmic ratio, very scanty cytoplasm, and also few nucleoli. And
right.
very hyperchromatic nature of nucleus is present. Huh? So this one is abnormal, this is a lymphoblast, and this one is a normal mature lymphocyte. So I think
Right.
you have got the idea of what is a blast, what is lymphoblast, and what is the difference between lymphoblast and myeloblast. You can see in the morphology Romanowski stain also, and also you can use the cytochemistry MPO, SBB, PAS, etc. And then by what advanced laboratory techniques you can confirm it, like the flow cytometry And again, you can classify it by the use of karyotyping and next generation sequencing. Okay, so always do remember that blasts are larger and having a high NC ratio, hyperchromatic nuclei, nucleoli will be present. Most of the time, nucleoli will be present. And also the importance of OR rod, importance of multiple OR rods, importance of MPO positivity in AML, and a very strong MPO positivity in APML, and the type of nucleus you see in AML and the type of nucleus, that bilobed kind of nucleus, reniform nucleus, you get in APML. And last but not the least, you can remember the lineage markers like MPO in myeloid, 19 for B, and cyto CD3 for T cells. T cells are having smaller numbers like 2, 3, 4, 8, 5, etc. And B cells are having larger numbers like 19, 20, 22, 79 alpha, etc. Any question? Anybody has any doubt? Okay, so I end my session here on, and if you have any doubt, you can ask me by next class. Thank you.
Why do we say this recurrent genetic anomaly? What is recurrent?
Recurrent means most commonly we get it, no? That is recurrent.
Oh, commonest.
More commonest. This is most commonly we get 821, 821. This is a recurring genetic abnormality. And जो अलग है, जो एक ही केस में very rarely मिलता है, हाँ, इसलिए these are actually the signature genetic abnormality. So that's why we call it for recurrent genetic abnormality. हाँ हाँ, अभी जस्मिता मैम करेंगे ना?